Okay, whenever I see an integral like this, where you've got a square root of two terms being added or subtracted, and they look like perfect squares, I'm thinking trigonometric substitution. So here's a Desmos graph that kind of shows you that there's the original function, or the integrand, and it looks like big F is an antiderivative, because if I graph F prime, I also get the same exact graph, and this table kind of confirms this. So I have a feeling that's the antiderivative right there, 1/75th of this mess. The question is, what does the work look like to get there? So whenever I'm thinking trigonometric substitution, I like to draw a little right triangle, and I want to use one of these three trig ratios: sine, secant, or tangent. So I think SST. And I want to do a trig substitution so that I clear the radical. So x squared minus 25 tells me that x is the hypotenuse, 5 is a leg. I want this to be theta, and I want to use a trig substitution secant, hypotenuse over the leg. So I'm putting the 5 here and the x squared of x squared minus 25 here. Okay, and now the secant of theta is x over 5, and that allows us to clear the radical. So x equals 5 secant theta dx, 5 secant theta tangent theta. Here's the work that shows you how we got rid of the radical. We really should probably have an absolute value symbol here, but for this problem, we won't worry about that. X to the fourth is 625 secant fourth theta. So we're ready to do the substitution. X squared of x squared minus 25, 5 tangent theta. Dx, 5 secant theta tangent theta d theta, and there's x to the fourth. We can take 5 times 5 is 25, divided into the 625, 1/25th out front. We've got 2 tangent squared factors, and secant theta over secant fourth theta becomes secant cubed theta. If I use trig identities for tangent and secant, I can reduce this to sine squared theta cosine theta. So this is where I want to find the antiderivative, and I can use U substitution for that. Pretty simple. I get 1/25th u squared du, antiderivative u squared, 1/3 u cubed, 1/75th sine cubed theta, the quantity cubed, because u sine of theta. And here's the key. By drawing that little right triangle, it's easy to come back here and figure out what the sine of theta is. Opposite over hypotenuse, square root of x squared minus 25 over x. There you go. And of course, you could write the numerator as the quantity x squared minus 25 to the 3/2 and all over x cubed. It might be a good experiment to take the derivative of this and make sure you get back to this. There you go. Hope that helped. If you have any questions, post a comment.